This is my last video about casting shadows, and it's going to be about shadows of cylinders. And if you want to know more about shadows, I have a whole nother YouTube site called Casting Shadows -o 7w. One way to find the cylinder shadow is to use the Terminator rectangle. First, find the center of each ellipse. Then determine where you want the front terminator to be so that light just grazes by its top. To find the back of the terminator, draw lines through the center of the ellipses to the back of the cylinder. To find the third pole, you have to divide this top into four parts so you can find this back pole. To finish the shadow, draw light rays through the top of the poles and lines from the shadow vanishing point through the bottom. And you can see that this part of the shadow is linear because it's from the vertical pole, whereas this part is round because it's from the round part of the cylinder. In this first cylinder, I set up a series of vertical poles to find the shadow. In the second, I used the Terminator rectangle to find the shadow. And since these light rays are parallel, the shadow lines are also nearly parallel. However, when you look at the same situation in this view, even though the light rays are parallel, the shadow lines begin to converge, and that's due to perspective. This image is a little more complex because the red cylinder is on top of the green one, but you carry out the same procedure of finding the three poles and then drawing light rays through the top of them. The only difference is that you have to bring the poles down to the casting surface to find the shadow lines. And notice when the shadow lines hit the green cylinder, they go vertically up and then graze right by this red cylinder to go to a new vanishing point here, which can be used for both sides of the cylinder. To find the shadow of this lemon, first turn it into a cylinder and then find the terminator. And you can find the terminator right here because it's the line between the light and the dark. So I made this the top of the terminator, and I drew a terminator rectangle so that the vertical poles touch the casting surface, so I can have shadow lines going through the bottom and light going through the top so I can find points on the shadow. You can also find cylinder shadows using my spokes method. So set up spokes on the can and draw light rays from the end of each spoke to find spoke shadows on the ground. And these shadows should go through one point. You can see that this shadow is smaller than the top of the can because it's further away. And this ellipse is very different from the casting ellipse. And yet my spokes method accurately found both shadows. The arc on this can is nearly identical to its shadow because the tops of the cans are parallel and the light rays are parallel. Similarly, this arc is very similar to its shadow on the ground. For this floating cylinder, start with the shadow direction and connect the two ends of the major axis of the base to find this ellipse on the ground. The shadow then goes vertically up, defining the width of this shadow, and to find the tilt of this ellipse, draw light rays from each end of the major axis of the cylinder. To find shadows of bowls, you could divide the bowl into ellipses and then find shadows of these ellipses. The problem is this approach is cumbersome, and it also doesn't tell us the width of the shadows. So instead, connect the rim of the bowl to an elliptical seat line on the ground. Then use light triangles to find the shadow. In this photo, we're looking up from the bottom of this hole. Find the ellipse that approximates the shadow line. The light ray travels through the major axis of this shadow ellipse, and the casting arc touches the shadow at 2 points. Now, if the light is more vertical like this, the shadow ellipse becomes longer and narrower still touching one side of the cylinder. The casting arc follows the rim of the bowl. It ends at these two red dots where the arc is tangent to the light. It casts this similarly shaped shadow on the ground with ends that are tangent to the light. Now, notice that the light area here connects to the shadow on the ground, and when you find such shapes, it makes shadow casting much easier. A cylinder is made up of ellipses where the ellipse looks like a line at eye level, and then they get wider as they move away from eye level. If the cylinder is on the side, there's one point where the ellipse is a line, and then they get wider as they move away from that line. When shading cylinders like tree trunks, try to follow these ellipses, and looping is a quick method of doing so. For a shiny cylinder, however, the shading should be linear, parallel to the sides. If it's hollow, draw lines through the center connecting areas of similar values. So number 1, the light area outside is connected to the light area inside, and number 3 is connected to number 4. But don't have number 1 and 2 vertically above one another because that would be confusing. To cross-hatch a cylinder, combine lines following the linear edges and curves following the round contour. They need to be relatively even and parallel to keep the cylinder from looking distorted. So this is the end of my Casting Shadows series, and check out my other YouTube site, Casting Shadows -07w.